So the first gas law we're going to explore in this video is from the English scientist Robert Boyle. Actually, quite an old law. This is before John Dalton's time in the early 1800s. But Boyle's law, and Boyle was very interested in hot air balloons and deep sea diving. So it's kind of not surprising that this scientist discovered a law between pressure and volume, which is that if pressure increases of a sample, the volume decreases. And we're assuming that the amount of gas or the moles of gas and the temperature of the gas remains constant. So you can visualize that phenomena in this little cartoon. If I have a sample of gas molecules at a certain volume and a certain pressure, if I contract that volume, if I make that volume smaller, the volume that those gas molecules are in, then those gas molecules don't have as much area to bounce around in and create pressure. So the pressure of that sample is going to increase. So that phenomena of pressure and volume being indirectly proportional is also really important for our lungs and with deep sea diving. And it's the reason why if you go deep sea diving, if you are at a depth that's pretty low down where the pressure is greater, when you ascend to a pressure that is less, you want to do that very slowly because the pressure in your lungs can equilibrate. If you ascend too quickly, then the pressure in your lungs could be such that they burst. That'd be a good thing. So that's all due to Boyle's law, which is that volume and pressure are indirectly proportional. So that means if volume goes down, pressure goes up, and vice versa. So mathematically, if we were to say that, we can use this little statement here in the blue that says that volume is indirectly proportional to pressure. But we could also write that in terms of a mathematical expression. If I have an initial pressure and an initial volume, like P1, V1, and if I have a final pressure, P2, we can then find the final volume, V2, by this statement down here. So this is another statement, a mathematical expression of Boyle's law that you will be using in this chapter, which is P1, V1 equals P2, V2. And we're going to use that in this next practice problem, where P1 is initial pressure, V1 is initial volume, P2 is final pressure, V2 is final volume. So let's say we have this scuba diving scenario where we have a snorkeler takes a syringe filled with 16 milliliters of air from the surface where the pressure is 1 atmosphere. So I have an initial volume and I have an initial pressure. Then it says at the end of his descent, so this snorkeler's going deep sea diving, at the end of his descent, the volume of air in the syringe is 7.5 mil. So we have a final volume. What is the pressure at this new depth? So we have P1, V1, and V2. We just need to find P2. So to do that, we kind of organize the information that we've been given. We need to find P2. From our equation P1 V1 equals P2 V2, we need to solve that for the variable P2. And so we can do that algebraically by taking this equation up here and then dividing both sides by V2. So I've done that up here. When you do that, then my V2 units cancel and I am left with this equation down here, which is P1 times V1 divided by V2 is equal to P2. Now I'm at the point where I can substitute my given values into that equation. And when I do that, I would really encourage you to do that, write down not only the number, but the unit. So you can easily see that, oh yeah, my milliliter units cancel. I'm left with something that's in atmospheres, ATM, which is great because that is a unit of pressure. And so doing that multiplication and division, if I was to go to 2 sig figs, I'm not going to be picky on significant figures with these problems, but for 2 sig figs, that would give me a pressure of 2.1 atmospheres.